Here we have a SAT math question. Okay, let's go to the question. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as a as a coefficient or the base? Okay, so the question says that f of 1 equals to k, and so k, the value of k must be either as a coefficient or the base. Actually, it's a back solving problem. That is, we have to check the given options one by one. So let me take the function. We have an option A, that is f of x equals to 50 times 1.6 to the power x positive 1. Okay, so in this option, what I need to do is I have to plug in 1 for x. Then I'm getting f of 1 equals to 50 times 1.6 to the power 1 positive 1. So f of 1 is equal to 50 times 1.6 to the power 2. So f of 1 is equal to 50 times, when I take 1.6 the whole square, so the value is 2.56. When I multiply 50 and 2.56, I'm getting 128. So the question says f of 1 equals to k. So when I plug in x equals to 1 into the first option, I'm getting f of 1 equals to 128. So what's the value of k? So the value of k is 128. According to the information I have in the question, the value of k must be either as the coefficient or the base. So look at the function. We have an option A. So this 128 must be the coefficient or the base. Actually, we don't find 128 over here. So we can reject option A. So because the value we get for k must be the coefficient or the base, but the value 128 we get for k from the function in option A is not being as a coefficient or the base over here in option A. So we can reject option A. Okay, now let me consider option B. So the function what we have in option B is f of x equals to 80 times 1.6 to the power x. So the same thing, I have to plug in x equals to 1 into this one, then I'm getting 80 times 1.6 to the first power. So because we plug in x equals to 1, then I'm getting f of 1 is equal to 80 times 1.6 to the first power is still 1.6. So f of 1 is equal to 80 times 1.6 is 128. Okay, still I'm getting the value of k as 128 in option B also. So the value of k is 128, but we don't find this value 128 as a coefficient or the base in the function in option B. So we can reject option B also. Okay, now let me consider option C. So 128 times 1.6 to the power x negative 1. Okay, the same thing, we have to plug in x equals to 1. Then I'm getting 128 times 1.6 to the power 1 negative 1. So f of 1 is equal to 128 to the power 1.6 times, 128 times 1.6 to the power 1 negative 1 will become 0. So f of 1 is equal to 128. Anything to the power 0 is equal to 1. So the value of this part is 1. So we get f of 1 is equal to 128. Okay, so in option C also, so we get 128 as the value of k. And also in option in the function given in option C, this 128, I mean the value of k, we get 128 is being as a coefficient for this term. So option C must be correct, because here we got k is equal to 128. That 128 is being as the coefficient of this term. So option C must be correct. Anyways, we can check option D also. So already we have rejected option A and option B. So now let's take the function given in option D, that is 204.8 times 1.6 to the power x minus 2. So now we can plug in x equals to 1 into this one. Then I'm getting 204.8 times 1.6 to the power of 1 negative 2. So 204.8 times 1.6 to the power of 1 negative 2 will become negative 1. And so since 1.6 having negative 1, so this term can be moved to the denominator. When I move it to the denominator, automatically this exponent negative 1 will become positive. So whenever the exponent is 1, we don't have to mention, or even if the value of 1.6 to the first power is still 1.6, it is 204.8 divided by 1.6. When I divide this 204.8 by 1.6, I'm getting 128. Okay, still I'm getting the value 128 for k. So in option D, we get k is equal to 128, but we don't find 128 in the function in option D, either as a coefficient or the base. So we can reject option D also. So in option C, when I plug in x equals to 1 into the function over here, I got k is equal to 128. This the value of k 128 is being as the coefficient for this term. So this is satisfied. This satisfies the condition given in the question. That is, the value of k should be the coefficient or the base. So here the value we get for k 128 is being as a coefficient for this term. So the correct answer choice for this question is option C.